Hello students, welcome to your channel Parivartan Physics. See, from this video we are starting the series of videos where we are going to learn 5-mark numerical problems for second PUC physics, right? Okay, see, in one more series of videos I have already started 5-mark important derivations from all the chapters. So on first chapter number 1 the derivations have been uploaded, chapter number 2 also the derivations have been uploaded. So that series of videos will also continue, and this series of videos of numericals will also continue. Along with this, I'm going to launch one more series of videos where I will be teaching for your KCET 2026. That series will surely prepare you very good for your KCET 2026. Dear students, if you like the content of this channel, please don't forget to subscribe and share this channel. So without wasting the time, let us begin the numerical problems on electric charges and fields. This video might be a little bit lengthy. It's ಸ್ವಲ್ಪ lengthy ಆಗ್ತದ್ರಿ, ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗ್ತದ video ಇಲ್ಲ ಅಂತಲ್ಲ, but I have taken almost all the possible different types of numericals in this. Right? So ಎಷ್ಟು possible different possible ways ಅದಾವ ಅಥವಾ different possible problems ಅದಾವ, ಅಷ್ಟು problems ಗಳನ್ನ ನಾನು ಇದ್ರೊಳಗೆ ಕವರ್ ಮಾಡಿದ್ದೀನಿ. Right? So this will surely prepare you completely for numericals from first chapter. Right? And we know very well, either from first chapter or second chapter you are going to get one 5-mark numerical. ಎರಡು ಚಾಪ್ಟರ್ ದಾಗಿಂದ ಒಂದು ಚಾಪ್ಟರ್ ಮೇಗಿಂದ 5-mark numerical ಶಾರ್ಟ್ ಬಂದೇ ಬರುತ್ತೆ. Right? So learn this carefully. Okay, let us begin then. See, first question is 3-point charges plus 3 nanocoulomb, minus 3 nanocoulomb and plus 2 nanocoulomb are placed at corners of an equilateral triangle ABC of side 0.3 meter in air. Right? Find resultant force acting on plus 2 nanocoulomb. Okay, so there is an equilateral triangle here. Let us take an equilateral triangle. Okay, so this is the equilateral triangle. Clear? Okay, this is the equilateral triangle we are taking here. This equilateral triangle is named as ABC. Okay, this is A, this is B, and this is C. Right? There are 3 charges placed. At point A, it is plus 3 nanocoulomb, plus 3 nanocoulomb. At point B, it is minus 3 nanocoulomb, minus 3 nanocoulomb. And at point C, it is plus 2 nanocoulomb. So these many charges are placed. What is the side of the square given us? Side of the square is 0.3 meter. Side of the square is 0.3 meter. Clear? Okay, now what we have to do is, we have to find out resultant force acting on plus 2 nanocoulomb charge. So, ಈ plus 2 nanocoulomb in point C ಒಳಗದ ಇದರ ಮೇಲೆ ಎಷ್ಟು force ಅದಾವ, that we have to calculate. How much is the net force on this? See, on any charge, ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಮೇಲೆ ಎಷ್ಟು number of forces act ಆಗ್ತಿರ್ತಾವ ಅಂತಂದ್ರೆ, how many charges are there in its surrounding. ಆ ಚಾರ್ಜ್ ದ ಸರೌಂಡಿಂಗ್ ಒಳಗೆ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಅದಾವೆ, those many individual forces will be acting on it. For example, here we want force on plus 2 nanocoulomb. So in the surrounding of plus 2 nanocoulomb, there are 2 charges, plus 3 nanocoulomb and minus 3 nanocoulomb. So on plus 2 nanocoulomb, there will be a force due to plus 3 nanocoulomb. There will be a force due to minus 3 nanocoulomb. So 2 forces will be acting on it. First, mark the direction of those forces. Our force of the directions ಗಳನ್ನು ಮೊದಲು ತೋರಿಸಿ. Okay, let me show the direction of the forces here. See, this is positive and this is also positive. So since both the charges are positive, like charges adav andmele, there has to be repulsive force between them. Repulsive force andre the forces must be acting away from each other. So on plus 3 nanocoulomb the force will be in this direction, on plus 2 nanocoulomb the force will be in this direction. And those forces should be shown along the straight line joining the 2 charges. ಎರಡು ಚಾರ್ಜಸ್ ಅನ್ನು ಜಾಯಿನ್ ಮಾಡುವಂತ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮೇಲೆ ತೋರಿಸಬೇಕು ನೀವು. So the force acting on plus 2 nanocoulomb due to plus 3 nanocoulomb is in this direction. Okay, let me take an arrow mark. Okay, so the force acting on plus 2 nanocoulomb due to plus 3 nanocoulomb will be in this direction. ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ನಮಗೆ ಇರ್ತದೆ. Correct? Repulsive force. Okay, this force I will call it as F1. F1 is the force on plus 2 nanocoulomb due to plus 3 nanocoulomb. Clear? Okay, next see, it has to be along the straight line only. Correct? Okay, next see, there will be one more force due to minus 3 nanocoulomb on this. Right? ಮತ್ತೊಂದು force ಇರಬೇಕು, ಅದು attractive ಇರಬೇಕು. Why? This is negative, this is positive. Attractive means the forces must be like this. On minus 3 it will be like this, on plus 2 it will be like this. Attractive force ನಾವು ಈ ತರ ತೋರಿಸಬೇಕು. So force on plus 2 we want force on plus 2. That's why I will show the force here. Correct? So this is the force on plus 2. Okay, I will call this force as F2. I will call this force as F2. Correct? So we are having two forces here, F1 as well as F2 antali ಎರಡು force ನಮಗೆ ಅದಾವ. Okay, so we got to know there are two forces acting on +2 nanocoulomb charge due to +3 nanocoulomb as well as -3 nanocoulomb. We want to find the net force on +2 nanocoulomb. So first you calculate F1 as well as F2. Force on +2 nanocoulomb and force due to +3 and force due to -3. Okay, let me calculate F1. F1. First write the formula clearly. 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. This is the formula, Coulomb's force. Right? Model formula bariri. Yakandre 5 marks numerical adava, you have to write the formula. Value of 1 by 4 pi epsilon naught is 9 into 10 raised to 9. 9 into 10 raised to 9. Q1 into Q2. Okay, we are writing the force between these two charges. So this is Q1 now, this is Q2. 3 nano into 2 nano. 3 into 2 will be 6. 6 nano into nano will be 10 to the power minus 18. How? See, 3 nano. 3 into nano means 10 to the power minus 9 into Q2. 2 nano. 2 into 10 to the power minus 9. So 3 into 2 will be 6 and it will be 10 to the power minus 9. Minus 9 will be minus 18. You have to add actually. Powers will get added. Okay. So we got to know how much will be the value. Okay, divided by R square. Divided by R square. How much is the R? R is 0.3, right? 0.3. Is 0.3, I can write it as 3 into 10 to the power minus 1. 0.3 means 3 into 10 to the power minus 1. So that square we have to take. Okay, 3 into 10 to the power minus 1 square. No problem, even if you take 0.3 as 0.3 square only. ಏನು ಸಮಸ್ಯೆ ಇಲ್ರಿ, ಹಿಂಗೆ ಬರ್ಕೋಬೇಕಂತೂ ಏನು ಸಮಸ್ಯೆ ಇಲ್ಲ. ನೀವು 0.3 ಇದ್ದದ್ದು ಆಸ್ ಇಟ್ ಇಸ್ 0.3 ಅಂತ ಬರ್ಕೊಂಡು ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಏನೂ ತಪ್ಪಿಲ್ಲ, ನಥಿಂಗ್ ರಾಂಗ್. ಇಫ್ ಯು ವಾಂಟ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್ ಲೈಕ್ ದಟ್ ಆಲ್ಸೋ. Okay, let me take it as it is then without making any changes. Okay, so this is 0.3 square. Correct? Okay, 9 into 6 will be 54. 9 into 6 will be 54 into 10 to the power plus 9, 10 to the power minus 18. So 10 to the power 9 minus 18 will be 10 to the power minus 9. 10 to the power minus 9 divided by 0.3 square. 0.3 square means it will be 0.09, right? Okay, let us calculate then. See, 0.3 into 0.3, 0.09. ಈಗ ನಾವು ಮೊದಲು ಏನು ಬರ್ಕೊಂಡಿದ್ವಿ, we had written it as 3 into 10 to the power minus 1, right? ಅದನ್ನ 3 into 10 to the power minus 1. ಇದನ್ನ ನಾವು ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಮ್ಗೆ ಏನು ಬರ್ತಿತ್ತು, 3 square is 9, 3 square is 9, 10 to the power minus 1 square ಅಂದ್ರೆ 10 to the power minus 2. So 9 into 10 to the power minus 2 means it is 0.09 only, 0.09 only. The same thing we have got, right? Just ನಮಗೆ ಹೆಂಗ್ ಬೇಕು ಆ ತರ ನಾವು ಈಸಿ ಆಗಿ ಹೋಗಿ ಬರ್ಕೊಬೇಕು ಅಷ್ಟೇ. Okay, it is left to you. Okay, so this is 0.09. 0.09. I will write this as 54 into 10 to the power minus 9 divided by 0.09 ಇದ್ದದನ್ನ ನಾನು 9 into 10 to the power minus 2 ಅಂತ ಬರೀತೀನಿ. 9 into 10 to the power minus 2. Okay, this is 9 ones are, this is 9 6s are 54. So I will get it as, ಇಲ್ಲಿ ನೋಡ್ರಿ 10 to the power minus 2 ಇದ್ರೊಳಗಿಂದ minus 2 ಹೋದ್ರೆ I will get 6 into 10 to the power minus 7. 6 into 10 to the power minus 7. This is F1. 6 into 10 to the power minus 7 Newton. Right? This is F1. Okay. We got F1. Now we'll calculate F2. F2 is this. See, F1 is the force between plus 3 nanocoulomb and plus 2 nanocoulomb. And what is the distance between the two charges? 0.3 only. F2 is the force between 2 and 3. Under same magnitude the charges are there. No doubt polarity is different, because of that only direction we have taken this side. Here also Q1 and Q2 were 3 and 2 only. Distance between them was 0.3 only. Here also Q1 and Q2 are 2 and 3 only, and distance between them is again 0.3, because it is equilateral triangle. Again 0.3. That's why even F2 will also be same. F2 kuda naಮಗೆ ಇಷ್ಟ ಬರ್ತದ್ರಿ. ಎಷ್ಟು? 6 into 10 to the power minus 7. This much force only we will get F2. So ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದನ್ನ F1 equal to F2 is equal to ಅಂತೇಳಿ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡ್ರು ನಡೀತದ್ರಿ, both together, right? So you will get F1 and F2 same, 6 into 10 to the power minus 7. Why same? Because both the charges are same and distance between the charges are same. If Q1 and Q2 are same and distance is same, force will be same. Correct? Okay, now you listen. Here This is equilateral triangle. This is equilateral triangle. Each angle or each vertex will be having how much angle? How much will be the angle? It will be 60 degree. Okay, if this is 60 degree, see, this angle is 180. This angle is 180. ಆ 180 ಒಳಗೆ ಇಲ್ಲಿ ನಮಗೆ 60 degree adre. Here we are having 60 degree. Okay, if this is 60 degree, then how much will be this angle? This will be 120 degree. This will be 120 degree. Yes, right. 120 plus 60, this will be 180 degree. Correct. So ನಮಗೆ ಬೇಕಾಗಿರೋದು angle between F1 and F2. Angle between F1 and F2 is 120 degree. 120 degree. Okay. See, one standard result you should be knowing. See, if P and Q are the two vectors which are equal, P ಮತ್ತು Q ಎರಡು ವೆಕ್ಟರ್ಸ್ ಈಕ್ವಲ್ ಇದ್ದು, ಆಮೇಲೆ ಅವರ ನಡುವೆ ಆಂಗಲ್ ಏನಾದರೂ, if the angle between them is 120 degree, then the resultant of those two vectors will be equal to P ಅಥವಾ Q ಅಂತ ನೀವು ತಗೋಬಹುದು. If two vectors are equal and angle between them is 120, resultant will be equal to any one of the two vectors. ಎರಡರಗಿಂತ ಯಾವುದಾದ್ರೂ ಒಂದು ವೆಕ್ಟರ್ ಈಕ್ವಲ್ ಇರ್ತದೆ. ಅಂದ್ರೆ ಇಲ್ಲ F1 ಮತ್ತು F2 ಈಕ್ವಲ್ ಅದಾವ್ರಿ, ಅವರ ನಡುವೆ ಆಂಗಲ್ 120 ಅದ ಅಂದಮೇಲೆ resultant has to be equal to F1 or equal to F2. ಯಾವುದಾದ್ರೂ ಒಂದು ಇರಬೇಕು. That is what we have to get, and that we will get here. ಅದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ತೋರಿಸಬೇಕಿಲ್ಲ. Okay, let me show. See, resultant force on plus 2 nanocoulomb, I will write it as F is equal to root of F1 square plus F2 square plus 2 F1 into F2 into cos theta. Correct? Cos theta. Now, basic then the start madatendre. I am not taking the direct result because this is a 5 mark numerical. So I am starting it from basic. Illantandre namagu already gottadre, if the angle between two equal vectors is 120, then resultant will be equal to any one of the vectors. Idu namagu already gottadu. That is what we have to calculate and show here. Okay, so this is equal to root of F1 and F2 both are equal. So I will write it like this: F1 square plus F1 square plus 2 F1 square, and this is cos 120 degree. Correct? F1 ಮತ್ತು F2 ಎರಡು equal adare. That's why I am taking it like this. F1 and F2 both are equal. That's why in place of F1, in place of F2, I am taking it as F1. Okay, so this will be root of F1 square plus F1 square ಅಂದ್ರೆ 2 F1 square plus ಇದು ನಮಗೆ 2 F1 square into cos 120 degree. How much is cos 120 degree? Cos 120 degree is minus 1 by 2. Minus 1 divided by 2. Correct? So then what I will get? I will get it like this: root of 2 F1 square minus into plus minus, 2 and 2 will get cancelled. So I will get it as F1 square. So 2 F1 square minus F1 square will be equal to root of F1 square. Root of F1 square means it is root of F1 square means here what happens? Square root and square will get cancelled. I will get it as F1. So finally I got F is equal to F1, which is equal to 6 into 10 to the power minus 7 Newton. So this much will be the force acting on that plus 2 nanocoulomb charge. ಈ ಚಾರ್ಜ್ ಮೇಲೆ ನಮಗೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತದೆ. ಕ್ಲಿಯರ್? ಓಕೆ. ಸೊ ಇಲ್ಲೇ ಕೆಲವೊಂದಿಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ನೆನಪಿಟ್ಕೋರಿ. ಇಫ್ ದೇರ್ ಆರ್ ಟೂ ವೆಕ್ಟರ್ಸ್ P and Q which are perpendicular to each other, resultant of these two vectors will be root of P square plus Q square. If there are two vectors P and Q which are in same direction, resultant will be equal to P plus Q. If there are two vectors P and Q which are opposite in direction, then resultant will be equal to P minus Q. Other than this, ಬೇರೆ ಯಾವುದೇ ಆಂಗಲ್ ಇತ್ತು, neither 90 nor 0 nor 180. ಇದು ನೋಡ್ರಿ, ಇದು 90 ಡಿಗ್ರಿ, ಎರಡು ವೆಕ್ಟರ್ಸ್ ನಡು 90 ಡಿಗ್ರಿ, ಇಲ್ಲಿ ಎರಡು ವೆಕ್ಟರ್ಸ್ ನಡು 0 ಡಿಗ್ರಿ, ಇಲ್ಲಿ ಎರಡು ವೆಕ್ಟರ್ಸ್ ನಡು 180 ಡಿಗ್ರಿ. Other than this, if there is any other angle, then you have to apply again this formula only, standard formula ನೀವು apply ಮಾಡಬೇಕು. Correct? In suppose if they are at 90 degree and if P is equal to Q, P ಮತ್ತು Q ಎರಡು ಈಕ್ವಲ್ ಇದ್ದು angle 90 degree ಇತ್ತಪ್ಪ ಅಂದ್ರೆ resultant will be equal to root 2P. Here, if both are equal P and Q, resultant will be equal to 2P, P plus P, 2P. If they are opposite in direction and if they are equal, if the vectors are equal and opposite in direction, resultant will be 0. Correct? Okay, so remember these things. We'll go for the next question. Okay, let us go to the next question then. See, 4 point charges, 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb and minus 5 microcoulomb are placed at corners of a square ABCD of side 10 cm respectively. Find force on 1 microcoulomb charge placed at the center of the square. ಸೊ ಇದು ಫೋರ್ಸ್ ಮೇಲೆ ಅದ ರೀ. ಇಲ್ಲಿ ನಮಗೆ ಜಾಮೆಟ್ರಿಕಲ್ ಫಿಗರ್ ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ? ಸ್ಕ್ವೇರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸ್ಕ್ವೇರ್ ಇಸ್ ಗಿವನ್, ರೈಟ್? ಸೊ ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಅ ಸ್ಕ್ವೇರ್ ಹಿಯರ್. ಓಕೆ, ಐ ಆಮ್ ಟೇಕಿಂಗ್ ಅ ಸ್ಕ್ವೇರ್. See, this is the square and the name of the square is given as ABCD. Name of the square is given as A, B, C and D, right? 4 charges are placed. At point A it is 2 microcoulomb. At point B it is minus 5 microcoulomb. At point C it is 2 microcoulomb. At point D it is minus 5 microcoulomb. Correct? These many charges are placed at the 4 corners. What is the side of the square? It is 10 centimeter. It is 10 centimeter. Correct? One more thing I have to tell you. Whenever the question is on square, you remember this. You remember this. If the side of the square is x, if the side of the square is x, then the length of the diagonal will be x root 2. Length of the diagonal will be x root 2. ಪ್ರತಿ ಸರಿ ನೀವು ಪೈಥಾಗರಸ್ ಥಿಯರಮ್ ಅಪ್ಲೈ ಮಾಡೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂತ ಏನಿಲ್ಲ. ಯು ರಿಮೆಂಬರ್ ದಿಸ್. ಲೆಂತ್ ಆಫ್ ದ ಡೈಗೋನಲ್, ಫುಲ್ ಡೈಗೋನಲ್ ಇಸ್ ಎಕ್ಸ್ ರೂಟ್. ಹಾಫ್ ಡೈಗೋನಲ್ ಅಂದ್ರೆ ಫ್ರಮ್ ಸೆಂಟರ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್ ಟು ದ ಕಾರ್ನರ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್, ದಿಸ್ ವಿಲ್ ಬಿ ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ 2. ಎಕ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ 2. ಫುಲ್ ಡೈಗೋನಲ್ ಎಕ್ಸ್ ರೂಟ್ 2, half diagonal x by root 2. You remember this. Every time you no need to calculate it continuously. ಈಗ ಇಲ್ಲೇ ನೋಡ್ರಿ, they have told that a charge is kept at the intersection of the diagonals. Nodri, find a force on 1 microcoulomb charge placed at the center of the square. Center of the square andre yavudu? Center of the square andre where the diagonals will meet. That is called center of the square, right? Okay, so let us draw the diagonals here. So these are the diagonals, right? Okay, ಈಗ this is called center of the square. Center of the square ಏನದ ಅದನ್ನ O ಅಂತ ಬರೀತೀನಿ. ಇಲ್ಲೇ ಚಾರ್ಜ್ ಎಷ್ಟು ಇಟ್ಕೊಂಡಿದ್ದಾರೆ? 1 microcoulomb charge is kept. So 1 microcoulomb charge is kept at the center of the square. Correct? Now we have to find out how much is the force acting on this 1 microcoulomb charge. ಈ 1 microcoulomb charge ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗುತ್ತೆ? I have told you already, on any charge how many forces will be acting, how many charges are in its surrounding. ಅದರ ಸರೌಂಡಿಂಗ್ ಒಳಗೆ ಎಷ್ಟು ಚಾರ್ಜಸ್ ಅದಾವ ಅಷ್ಟು ಫೋರ್ಸ್ ಅದರ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತಿರ್ತಾವ್ರಿ. ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಪೊಲಾರಿಟಿ ಅದು ಅಟ್ರಾಕ್ಟಿವ್ ರಿಪಲ್ಸಿವ್ ಅನ್ನೋದು ಆಮೇಲೆ ಡಿಸೈಡ್ ಆಗ್ತದೆ. ಕರೆಕ್ಟ್? ಸೊ ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈ 1 microcoulomb ಚಾರ್ಜ್ ಮೇಲೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಬೇಕಿಲ್ಲ? ಹೌ ಮೆನಿ ಇಂಡಿವಿಜುವಲ್ ಫೋರ್ಸಸ್ ವಿಲ್ ಆಕ್ಟ್? 4 ಇಂಡಿವಿಜುವಲ್ ಫೋರ್ಸಸ್. 1 2 3 4 ಚಾರ್ಜಸ್ ಆರ್ ದೇರ್. 4 ಇಂಡಿವಿಜುವಲ್ ಫೋರ್ಸಸ್ ಮಸ್ಟ್ ಆಕ್ಟ್ ಆನ್ ಇಟ್. ಸೊ ಲೆಟ್ ಅಸ್ ಮಾರ್ಕ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಆಲ್ ದೀಸ್ ಫೋರ್ಸಸ್. ಈ ಫೀಲ್ಡ್ ಮತ್ತು ಫೋರ್ಸ್ ಮೇಲೆ ಏನಾದರೂ ಫೋರ್ಸ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಬಂದ್ರೆ ಮೊದಲು ನೀವು ಡೈರೆಕ್ಷನ್ಸ್ ಹಾಕೋದು ಮರಿಬೇಡಿ. ಫಸ್ಟ್ ಯು ಡ್ರಾ ದ ಡಯಾಗ್ರಾಮ್, ಪುಟ್ ದ ಡೈರೆಕ್ಷನ್ಸ್ and then you will get the idea to solve it. Correct? Okay, so plus 2 microcoulomb plus 1 microcoulomb, both are positive. ಅಂದಮೇಲೆ ಫೋರ್ಸ್ ಏನಿರ್ಬೇಕ್ರಿ? ರಿಪಲ್ಸಿವ್. ಸೊ ಪ್ಲಸ್ 1 microcoulomb ಮೇಲೆ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇರಬೇಕು, 2 microcoulomb ಮೇಲೆ ಈ ಡೈರೆಕ್ಷನ್ ಮೇಲೆ ಇರಬೇಕು. ನಮಗೆ ಕೇಳಿದ್ರೆ ಫೋರ್ಸ್ 1 micro ಮೇಲೆ ಅಷ್ಟೇ. ಸೊ ಶೋ ಫೋರ್ಸ್ ಓನ್ಲಿ ಆನ್ ದಿಸ್ ಚಾರ್ಜ್, ನಾಟ್ ಆನ್ ದಿಸ್ ಚಾರ್ಜ್. ಸೊ ಫೋರ್ಸ್ ಆನ್ 1 microcoulomb will be in this direction. It is in this direction. Correct? This is force on 1 microcoulomb due to 2 microcoulomb. I will call this force as F1. ಇದನ್ನ F1 ಅಂತ ಕರೀತೀವಿ. Next, plus 1 microcoulomb minus 5 microcoulomb. This is positive, this is negative, so the forces must be attractive ಇರಬೇಕು. So force on 1 micro will be in this direction due to minus 5 micro at B. Okay, it will be exactly along the diagonal. Okay, so this is exactly on the diagonal. Okay, I will call this force as F2, force acting on 1 micro due to minus 5 micro. Next, this is plus 2 microcoulomb, this is plus 1 microcoulomb. Anmele repulsive force irbeku, like charges. So force on this direction, force on this direction. Okay, so I will show that force here. Force number 3. Right? Okay, I will call this force as F3. Next, this is minus 5, this is plus 1. Opposite charges are there, unlike charges, so there has to be repulsive force. So force on plus 1 microcoulomb due to minus 5 microcoulomb will be in this direction. Idu namagu ee direction ಒಳಗೆ ಇರ್ತದೆ. Correct? I will call this force as F4. So totally 4 forces are acting there on 1 microcoulomb charge. Total 4 forces are acting. So what we have to do is, we have to calculate these 4 forces first. ಈ ಇಂಡಿವಿಜುವಲ್ ಫೋರ್ಸಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕಿಂತ ಮುಂಚೆ ಸ್ವಲ್ಪ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ ನೋಡ್ರಿ. Little bit you observe and see. F1 is force between which two charges? It is force between 2 microcoulomb and 1 microcoulomb. 2 microcoulomb and 1 microcoulomb. What is the distance between 2 microcoulomb and 1 microcoulomb? It is OA. Distance between them is OA. Next, what about F3? F3 is the force between again 2 microcoulomb and 1 microcoulomb. It is also again the force between 2 micro and 1 micro. And what is the distance between them? It is OC. And however, OC and OA both will be equal. So, charges are same, and distances are also same. Andmele, these both forces will be same. F1 ಮತ್ತು F3 ಎರಡು equal ಇರ್ತಾವ್ರಿ. Correct? Next, ಅದೇ ತರ F2 force between 1 micro and minus 5 micro. Distance between them is OB. F4 force between 1 micro and minus 5 micro. Distance between them is OD. So charges are same, distance is same. Andmele, these both forces will be equal. Right? It means that F1 and F3 are equal. F1 and F3 are equal. Similarly, F2 and F4 are equal. ಇವು ಎರಡು forces ನಮಗೆ equal ಅದಾವೆ. See, these forces are equal. These forces are equal and they are opposite in direction. F1 and F3 are equal, they are opposite in direction. So they will get cancelled out. Athra the resultant 0 ಆಯ್ತು. F2 and F4 are equal, they are opposite in direction, they will get cancelled. So resultant will become 0. Andmele, there is no resultant force on this diagonal, there is no resultant force on this diagonal, hence the force on 1 microcoulomb will be 0. We already got to know it, it is 0 anta, but we have to calculate and show it. ಅದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ತೋರಿಸಬೇಕು. ಓಕೆ, ಈಗಲೇ ನೋಡ್ರಿ, ಸೈಡ್ ಆಫ್ ದ ಸ್ಕ್ವೇರ್ ನಮಗೆ 10 ಸೆಂಟಿಮೀಟರ್ ಅದ. ಓಕೆ, ನಾವು ಐ ವಿಲ್ ರೈಟ್ OA is equal to OB is equal to OC is equal to OD. These four values will be same. ಇವು ನಾಲ್ಕು ತರದ ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಇರ್ತದ್ರಿ. I have told you half diagonal means x by root 2. So this is 10 divided by root 2 centimeter. 10 divided by root 2 centimeter. In meter if you want, it is 10 divided by root 2 into 10 to the power minus 2 meter. Correct? Okay, this is the distance. Okay, now calculate F1 and F3. First write the formula. Formula is 1 divided by 4 pi epsilon naught Q1 into Q2 divided by R square. This is the formula. Correct? This is the formula. Next, 1 by 4 pi epsilon naught means 9 into 10 raised to 9. Q1 into Q2. What is Q1? 2 micro. What is Q2? 1 micro. So 2 into 1 will be 2. Micro into micro will be 10 to the power minus 12. Minus 6 into minus 6. 10 to the power minus 6 into 10 to the power minus 6. It will be 10 to the power minus 12. Divided by distance square. R. How much is the distance? 10 by root 2. 10 divided by root 2 into 10 to the power minus 2 whole square. 10 to the power minus 2 whole square. Correct? Okay, let us again simplify this. Ignore it. Idu 9 into 2, it will be 18. 18. 10 to the power plus 9 minus 12. Plus 9 minus 12 will be minus 3. So this is 10 to the power minus 3. Divided by, see, 10 square. 10 square into, either 10 kana square apply mani. Idu 10 to the power minus 2 into 2. 10 to the power minus 4. Divided by root 2 square, it will be 2. Correct? So this 2 will come to the numerator. Or the 18 multiply ಆಗ್ತದ್ರಿ. So that it will become 36. It will become 36. 10 to the power minus 3 divided by, ಇಲ್ಲಿ ನಮಗೆ 10 to the power plus 2 minus 4 ಅದ. So ಇಲ್ಲಿ ಎಷ್ಟು ಉಳಿತ? 10 to the power minus 2 ಉಳಿತು. Minus 2 is remaining. So 10 to the power minus 2 from this, minus 2 from this will get cancelled. What will be remaining there? In the numerator, you will get 10 to the power minus 1. 10 to the power minus 1. Correct? So this is 36 into 10 to the power minus 1. Or simply you can write it as 3.6 Newton. This much force you can write. Correct? So that is the force F1 as well as F3. F1 as well as F3. F1 is also 3.6 Newton. F3 is also 3.6 Newton. Right? Clear? Hope you have understood the calculation clearly. Next, since F1 and F3 are acting on the same straight line but they are opposite in direction, resultant of these two forces, I will call it as F13. Resultant of these two forces, that will be equal to F1 minus F3, and which is nothing but 0 Newton. Right? So resultant F13 is 0 Newton. 0 Newton. Similarly, calculate F2 and F4. So if you want to calculate F2 and F4, again we have to first write the formula. Write the formula. Formula is 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. Right? What is 1 by 4 pi epsilon naught? It is 9 into 10 raised to 9. 9 into 10 raised to 9, Q1 into Q2, 5 micro into 1 micro. Here this is Q1, this is Q2. Don't take the sign here. First chapter ಒಳಗೆ formulas ದಾಗ sign ಹಾಕ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ. Field ಆಯ್ತು, force ಆಯ್ತು. So 5 into 1 will be 5. Micro into micro will be 10 to the power minus 12 divided by distance square, that is 10 divided by root 2 into 10 to the power minus 2 whole square. Correct? Correct? So 9 into 5, this will be 45. 45 into 10 to the power plus 9, 10 to the power minus 12 will be 10 to the power minus 3 divided by, this is 10 square into 10 to the power minus 2 whole square will be 10 to the power minus 4 divided by root 2 square means it will be 2. Correct? So 2 will multiply to the numerator, it will become 90. 45 into 2. So this is 10 to the power plus 2 minus 4. It will be 10 to the power minus 2 plus 2 minus 4. In the numerator we have 10 to the power minus 3. Correct? Minus 2 from this, minus 2 from this will get cancelled. What I will get? I will get 90 into 10 to the power minus 1. 90 into 10 to the power minus 1. So that is nothing but 9 Newton. 9 Newton. So this is F2 and F4. So we got F2 is equal to F4 is equal to 9 Newton. Correct? This much we got. Okay. So this is 9 Newton. Let me write the answer here. So this is 9 Newton. Okay. So F2 is also 9 Newton, F4 is also 9 Newton. So the resultant of these two, I will call it as F24. F24 will be equal to F2 minus F4, which is equal to 0 Newton. Since F13 is also 0 Newton and F24 is also 0 Newton, resultant force acting on, resultant force on 1 microcoulomb is 0 Newton, right? It is 0 Newton, right? This is how we have to calculate it. Okay, that's all about the force on the charge kept at the center of the square. We'll go for the next question. See, next question is 2 point charges 10 microcoulomb and 20 microcoulomb are placed at corners of a hypotenuse BC of a right angled triangle ABC of side AB equal to 3 cm, AC equal to 4 cm. Calculate resultant electric field at point A. Previous two questions were on force. Now they are asking us electric field. Correct? Okay. Which geometrical figure they have given? Right angled triangle they have given. Okay, let us draw the right angled triangle first. See, this is the right angled triangle. I will name that right angled triangle as hypotenuse ಏನದ ಅಂತ ಹೇಳಿದಾರೆ ನೋಡ್ರಿ, are placed on the hypotenuse BC. Hypotenuse is BC. So this is B and this is C. Then this is A. This point is A. What they have told, 2 point charges 10 microcoulomb and 20 microcoulomb are placed at the corners of hypotenuse of BC. So at B, the charge is 10 microcoulomb. I will take this charge as B ಒಳಗೆ ಏನು ಚಾರ್ಜ್ ಅದ ಅದನ್ನ ನಾವು 10 microcoulomb Q1 ಅಂತ ತಗೊಳ್ಳೋಣ. C ಒಳಗೆ ಏನು ಚಾರ್ಜ್ ಅದ ಅದನ್ನ ನಾವು 20 microcoulomb Q2 ಅಂತ ತಗೊಳ್ಳೋಣ. Let us take it as Q2. Correct? Sides they have given now. What are the sides? AB is 3 cm. This is 3 cm. And what about AC? AC is 4 cm. This is 4 cm. Right? So now calculate resultant electric field at point A. You have to calculate the electric field at A. At any point, ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಒಳಗೆ how many electric fields will be there? How many charges are in its surrounding? ಎಷ್ಟು ಚಾರ್ಜಸ್ ಆ ಪಾಯಿಂಟ್ ದ ಸರೌಂಡಿಂಗ್ ಒಳಗೆ ಅದಾವ ಅಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ಅಲ್ಲಿ ಇರ್ತಾವ್ರಿ. You have to mark those electric fields. ಅಂದ್ರೆ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ನೀವು ಮಾರ್ಕ್ ಮಾಡಬೇಕು. ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಔಟ್ವರ್ಡ್ಸ್ ಫ್ರಮ್ ದ ಚಾರ್ಜ್, ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್ಸ್ ಫ್ರಮ್ ದ ಚಾರ್ಜ್, ಅವೇ ಫ್ರಮ್ ದ ಚಾರ್ಜ್. ನೆಗೆಟಿವ್ ಇದ್ರೆ ರೇಡಿಯಲಿ ಇನ್ವರ್ಡ್ಸ್ ಆರ್ ಟುವರ್ಡ್ಸ್ ದ ಚಾರ್ಜ್ ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. ಕರೆಕ್ಟ್? ಹಿಯರ್ ಬೋತ್ ದ ಚಾರ್ಜಸ್ ಆರ್ ಪಾಸಿಟಿವ್. ಸೊ ಲೆಟ್ ಅಸ್ first mark the direction of the electric fields. Q1 plus 10 microcoulomb. So each charge the electric field ನಮಗೆ radially outwards ಇರಬೇಕು. It has to be away from the charge. Away from the charge ಅಂತಂದ್ರೆ ಆ electric field ನೀವು ಇಲ್ಲೇ ತೋರಿಸಬೇಡ್ರಿ. You don't show it here. ಯಾವ ಪಾಯಿಂಟ್ ದಾಗ ನಿಮಗೆ electric field ಕೇಳಿದಾರೆ? A ಪಾಯಿಂಟ್ ಒಳಗೆ. So start the vector from point A where they have asked you. ಯಾವ ಪಾಯಿಂಟ್ ಒಳಗೆ ನಿಮಗೆ ಕೇಳಿದಾರೆ ಆ ಪಾಯಿಂಟ್ ದಿಂದ ವೆಕ್ಟರ್ ನ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ. ಕರೆಕ್ಟ್? So Q1 ಅಂತ ಏನು ಚಾರ್ಜ್ ಅದ, ಈ Q1 ಚಾರ್ಜ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪಾಯಿಂಟ್ ಎ ಒಳಗೆ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. It is positive charge, right? Okay. So Q1 is positive charge, hence we have to take electric field outwards from it. ಅದರಿಂದ outwards ನಾವು ತೋರಿಸಬೇಕು. Okay, this is the electric field of Q1. I will write this electric field as I will write this electric field as E1. E1 means it is electric field of Q1. Similarly, what about Q2? Q2 is also positive charge plus 20 microcoulomb. So positive on electric field outwards away from the charge. So I will show that electric field here. I will show that electric field here. Okay. So this is the electric field, right? Exactly along that line only it will be. Then AC line AC line okay. So along that straight line only it will be acting. So this is E2. E2 this is E2. Angle between E1 and E2 is 90 degree. They are perpendicular to each other. Okay. So first what you do, you calculate E1 and E2. ಮೊದಲು ನೀವು E1 ಮತ್ತು E2 calculate ಮಾಡಿದ್ರೆ. Calculate E1 and E2. Okay. E1. Write the formula of electric field of a point charge. Electric field of a point charge is given as 1 by 4 pi epsilon naught Q divided by R square. This is the formula of electric field. Okay, 1 by 4 pi epsilon naught is 9 into 10 raised to 9. Q, what is Q? I mean Q1, E1 antadre ನೀವು Q1 ಅಂತ ತಗೋಬೇಕು. Q1 is 10 microcoulomb. So 10 into 10 to the power minus 6 divided by R square. How much is the distance? Distance is 3 centimeter. You take it in meter. ಅದನ್ನ meter ಒಳಗೆ ತಗೊಳ್ರಿ. 3 into 10 to the power minus 2 whole square ಅಂತ ನಾ ಬರೀತೀನಿ. 3 into 10 to the power minus 2 whole square. Correct? Okay, let us simplify this then. This now simplify ಮಾಡ್ಕೊಳ್ಳೋಣ. See 9. See we are having 10 to the power plus 1 here. This is 10 to the power plus 1. This is 10 to the power plus 9. So 9 plus 1 10. 10 minus 6 4. So it will be 9 into 10 to the power plus 4. ಹೆಂಗ ಇದು 10 to the power 9 ಮತ್ತು 1 ಇದು 10 ಆಯಿತು minus 6 ಆಯಿತು. Right? It will be 10 to the power plus 4. Okay? Bigger sign is positive. 10 the sign positive, the 6 sign negative, so positive. Divided by 3 square, it will be 9. 10 raised to minus 2 square, it will be 10 to the power minus 4. 9 and 9 will get cancelled. If this 10 comes to the numerator, it will become 10 to the power plus 4. So 1 into 10 to the power 4 and this 4 will get added to that. It will be 10 to the power 8. 10 to the power 8. So we got electric field. Don't forget to write the unit Newton per coulomb or volt per meter. This is electric field E1 at point A. Similarly, you have to calculate electric field E2 at point A. So let us calculate E2 then. E2. See E2, again write the formula 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q2 divided by R square. 1 by 4 pi epsilon naught is 9 into 10 raised to 9. What is Q2? Charge number 2, that is 20 microcoulomb. So 20 into 10 to the power minus 6 divided by R square. R, how much is R? R is 4 centimeter. I will take it in meter. 4 into 10 to the power minus 2 whole square. Meter. Okay. Next, 9 into 20 will be 180. 9 into 20 will be 180. 10 to the power plus 9 minus 6 will be 10 to the power plus 3. 10 to the power plus 3. Correct? Divided by 4 square. 4 square is 16 into 10 to the power minus 2 square will be 10 to the power minus 4. 10 to the power minus 4. I can write it like this. Here I am having 180. 180 is 0 antade. 0 means it is 10 to the power plus 1. 1 0 andre 10 to the power plus 1. So 10 to the power plus 1, 10 to the power plus 3, 10 to the power plus 4. Right? So this will be 18 into 10 to the power plus 4 divided by 16 into 10 to the power minus 4. Clear? 16 into 10 to the power minus 4. So this will be 2 9s are 18 and 2 8s are 16. So we will get 9 divided by 8 into minus 4 milgade hoytare plus 4 ಆಗ್ತದ್ರಿ 10 to the power plus 8. 10 to the power plus 8. Yes. Now 9 divided by 18 we want. 9 divided by 18. So let us calculate 9 divided by 18. One sec. It has to be 1 point something. Okay, 9 divided by 18 we want. Just a minute. Okay, so we'll take up the calculator here. Okay, 9 divided by 18 we want. 9 divided by, sorry, 18 alla 8. 9 divided by 8. It is 1.125. So E2 is 1.125 into 10 to the power 8 Newton per coulomb. This much we get. This is E2. This is E2. Now, next we have to calculate the resultant electric field at point A. Resultant electric field at point A. See how many electric fields are there? E1 and E2. There are two electric fields at point A. How they are? They are perpendicular to each other. If they are perpendicular to each other, resultant will be in between them like this. ಈ ತರ ನಮಗೆ resultant ಇರ್ತದೆ. And this resultant I will write it as E. Since E1 and E2 are perpendicular, this resultant electric field at A will be equal to root of E1 square plus E2 square because they are perpendicular to each other. ಒಂದಕ್ಕೊಂದು perpendicular ಅದಾವ. So resultant electric field at A, it will be root of E1 square plus E2 square. So we have to simplify this now. E1 square, E2 square, E1 value substitute matter, it is 1 into 10 raised to 8 square, 1 into 10 raised to 8 square, plus E2, it is 1.125 into 10 raised to 8 square, right? So we have to simplify this. This will be root of 1 square is 1, 10 raised to 8 square is 10 raised to 16, plus 1.125 into 1.125 into 1.125. So this is 1.265. I will take it as 1.265 into 10 raised to 16. Correct? If I take 10 raised to 16 common, I will get it as 1 plus 1.265, that is 2.265 into 10 to the power 16 is common. Correct? So root of 2.265, right? Root of 2.265. Square root of 2.265. 2.265 square root of this. It is 1.50, right? So 1.50 into 10 to the power square root again the 10 to the power 16 ಹೊರಗಡೆ ತಗೊಂಡ್ರೆ it will be 10 to the power 16 divided by 2, which is nothing but 10 to the power 8, right? 10 to the power 8 Newton per coulomb. So this much will be the electric field. 10 to the power 8 Newton per coulomb. This much will be the electric field at point A. Clear? One more thing I want to tell you here. See, if there are, these are the two vectors P and Q which are perpendicular to each other, and we know if two vectors are perpendicular to each other, then the resultant vector of them will be P square, root of P square plus Q square, perpendicular idre. If P and Q are equal, if P and Q both are equal, then resultant will be equal to P. Resultant will be equal to P. ಈಗ P ಮತ್ತು Q ಎರಡು ಈಕ್ವಲ್ ಇದ್ದು ರಿಸಲ್ಟೆಂಟ್ P ಅಂತ ಬಂತಪ್ಪ ಅಂದ್ರೆ ವೇರ್ ದಿಸ್ ರಿಸಲ್ಟೆಂಟ್ ವಿಲ್ ಬಿ, ಈ ರಿಸಲ್ಟೆಂಟ್ ಎಲ್ಲಿ ಇರ್ತದ್ರಿ? ಇಟ್ ವಿಲ್ ಬಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇನ್ ಮಿಡಲ್ ಆಫ್ ದಮ್. ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇನ್ ಮಿಡಲ್ ಆಫ್ ದಮ್ ಅಂತಂದ್ರೆ P ದಿಂದ 45 ಡಿಗ್ರಿ, P ದಿಂದ 45 ಡಿಗ್ರಿ, Q ದಿಂದ 45 ಡಿಗ್ರಿ, ಈಕ್ವಲ್ ಹಾಫ್ ದಾಗ ಡಿವೈಡ್ ಮಾಡಿರ್ತದ್ರಿ ಆ 90 ಡಿಗ್ರಿ. ಬಟ್ ವೆನ್ P and Q are equal, what if P is greater than Q? If P is greater than Q, then the resultant vector will be close to P. It will be close to P, right? Resultant vector will be close to P, far away from Q. Close to P andre angle between P and R will be less than 45 degree, and angle between Q and R will be greater than 45 degree. If Q is greater than P, then that resultant vector will be close to Q. It will be close to Q. It means angle between Q and R will be less than 45. Angle between P and R will be greater than 45. Correct? This is what you have to understand. Okay. Let us go to the next question then. See, next question is 3 charges. I am telling you again, video might be lengthy. I have taken many number of questions here, but almost all the types I have covered. Right? So you will get prepared solidly for this chapter, numericals. So go through the video clearly. Fourth question. 3 charges each equal to plus 4 nanocoulomb are placed at 3 corners of a square of side 2 cm. Find resultant electric field at 4th corner. Square ada 4th corner ಒಳಗೆ ನಮಗೆ resultant electric field find ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. So let us draw square first. Okay, this is the square, right? This is the square, and at the 4 corners of the square, plus 4 nanocoulomb charges are placed. Same charges place ಮಾಡಿದ್ದಾರೆ. ಇಲ್ಲೂ ಕೂಡ plus 4 nanocoulomb, ಆಮೇಲೆ ಇಲ್ಲೂ ಕೂಡ plus 4 nanocoulomb, ಆಮೇಲೆ ಇಲ್ಲೂ ಕೂಡ plus 4 nanocoulomb. So 3 charges are kept at 3 corners. If you want, you can take this charge here also, nothing to worry. ಒಂದು ಕಾರ್ನರ್ ಖಾಲಿ ಇರಬೇಕು ಅಷ್ಟೇ. Find resultant electric field at 4th corner they are asking. Side of the square they have given it as 2 centimeter. Side of the square they have given it as 2 centimeter. Let me name the square. It is A, this is B, this is C, and this is D. We want to find electric field at C. Electric field at C now find ಮಾಡಬೇಕು. Okay, side of the square is 2 centimeter. Then how much will be the distance in ಅಥವಾ diagonal ಎಷ್ಟು ಇರ್ತದ್ರಿ? Diagonal A to C diagonal. How much will be this? The A to C diagonal ಏನದಲ್ಲ, it will be x root 2. X root 2. So I will write here AC is equal to 2 root 2 centimeter. Meter ಒಳಗೆ ಬೇಕಾದ್ರೆ 2 root 2 into 10 to the power minus 2 meter. Correct? So this is the distance AC. Okay. First, mark the directions of the electric fields. How many electric fields will be there? Since there are 3 charges, plus 4, plus 4, plus 4, there will be 3 electric fields. 3 electric fields ಇರ್ತಾವೆ. ಆ 3 electric fields ಗಳನ್ನು mark ಮಾಡ್ರಿ. Electric field of plus 4 nanocoulomb at A, since it is positive, electric field has to be away. Start from C and it has to be away from that charge. Correct? Exact ಅದೇನು diagonal ಇದೆ, diagonal ಮ್ಯಾಗೆ ಇರ್ತದೆ. Okay, along the diagonal only it will be. This is E1. This is E1. Electric field due to the charge at point A. Next, electric field due to the charge at point B. Since this is positive, field has to be away. Away iruwanta field na ee kade draw ಮಾಡ್ತೀನಿ. Correct? So this is E2. E2, electric field due to the charge at B. Next, electric field at point C due to plus 4 nanocoulomb at D. Idu positive ada, positive andmele electric field has to be radially outwards. Start from C, it will be in this direction. E direction ಒಳಗೆ ನಮಗೆ ಇರ್ತದೆ. So this is E3 ಅಂತ ನಾ ಕರಿತೀವಿ. This is E3. So totally there are 3 electric fields. Hope the pink color vectors are visible to you. Yes. Well, so here there are 3 electric fields, E1, E2, E3. Correct? We have to find out the resultant electric field of this. Ille first ಒಂದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. Tell me which 2 electric fields are equal in this 3. E1, E2, E3 ಒಳಗೆ ಯಾವ electric fields equal ಅದಾವ? Where charge is same, distance is same, their electric field will be same. Because electric field is E is equal to 1 by 4 pi epsilon Q divided by R square. It depends on charge and distance. If charge and distance are same, electric field will be same. See, electric field at B is 4 nanocoulomb. Distance of C from that B is 2 centimeter. Electric charge at D is 4 nanocoulomb. Distance of that D from C is 2 centimeter. 4 nano, 2 centimeter, 4 nano, 2 centimeter. So electric field of this charge and this charge has to be same. Andre E3 and E2, these both will be equal. E1 is not equal to that, even though charge is same. Charge 4 nanocoulomb ada, other distance bare irtade. Distance namage ಎಷ್ಟು ಬರ್ತದೆ? Distance is different. So E1 is not equal. Correct? So which 2 electric fields are equal then? E2 and E3 are equal. E2 and E3 are equal. You can calculate these two together. You don't know at a time you calculate ಮಾಡ್ಕೋಬಹುದು. You can calculate it as E2 is equal to E3. Together you can calculate. I have told you, if two vectors are perpendicular, then the resultant will be equal to root of p square plus q square. If those two vectors are equal and perpendicular, resultant will be root 2p. Right? So if ಎರಡು ತರದ resultant ನಮಗೆ ಎಷ್ಟು ಇರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ it will be root 2p. ಎಷ್ಟು ನಮಗೆ resultant ಇರ್ತದೆ. That is what we are going to get. So let us calculate that. Okay, E1 is equal to E2. ಇವೆರಡು ನಮಗೆ ಈಕ್ವಲ್ ಅದಾವ. ಸೊ ಇವೆರಡನ್ನೂ ಕೂಡಿ ನಾ at a time calculate ಮಾಡ್ಕೊತೇನೆ. Write the formula first. It is 1 divided by 4 pi epsilon naught q divided by r square. This is the formula. So we'll continue it from here. 1 by 4 pi epsilon naught means it is 9 into 10 raised to 9. Q is 4 nanocoulomb. 4 into 10 to the power minus 9 nano ಅಂತಂದ್ರೆ divided by r square. Distance is 2 centimeter. ಅದನ್ನ ಮೀಟರ್ ಒಳಗೆ ಬರ್ಕೋತೀನಿ. 2 into 10 to the power minus 2 whole square. Correct? 9 into 4, this will be 36. 9 into 4, 36. 10 to the power plus 9, 10 to the power minus 9 will get cancelled. Correct? It will get cancelled. Okay. So I will get 36 divided by 2 square is 4. 10 to the power minus 2 square will be minus 4. 4 ones are 4 nines are 36. So we'll get 9 into 10 to the power 4 Newton per coulomb. This much is the value of E2 as well as E3. ಇಷ್ಟು ನಮಗೆ E2 ಮತ್ತು E3 the value adare. Correct? Okay. So we got the values of E2 and E3. Now let us find out the resultant of E2 and E3. Idu E2 as well as E3. Now let us find out the resultant of E2 and E3. Since E2 and E3 are perpendicular, since E2 is perpendicular to E3, E2 is perpendicular to E3, resultant of these two vectors E2, 3 will be equal to root of E2 square plus E3 square. E2 square plus E3 square. So this is root of E2 square. Nodri, E2 ಮತ್ತು E3, these both are equal. So I will write it as E2 square plus E2 square, which is nothing but root 2 E2 square. I will get it as root 2 E2. I will get it as root 2 E2. Value of E2 is already known. So this will be root 2 ಅಥವಾ ಇಲ್ಲಿ ನಮಗೆ 9 ಅಂದರೆ 9 into 10 raised to 4. I will write it as 9 root 2 into 10 raised to 4 Newton per coulomb. This much is the resultant. E23. This much is the resultant. E23. I have told you this clearly. If two vectors are perpendicular to each other, and if these two vectors are equal, ಎರಡು vectors perpendicular ಇದ್ದು ಅವು ಎರಡು equal ಇದ್ದುಪ್ಪ ಅಂತಂದ್ರೆ resultant of those two will be exactly at 45 degree from P and 45 degree from Q. Correct? Here will be the resultant. Exactly. Since E2 and E3 both are equal, the resultant will exactly be at 45 degree. 45 degree andre it will be along E1. Why along E1? Because E1 is acting along the diagonal. Diagonal will always be at 45 degree from one side and 45 degree from other side. Correct? So here E23 will be along E23 then I will show the direction of E23 here. E23. So E23 will also be acting along this direction only. I mean along E1 only. Right? Here let me write it as this is E23. E23. Right? E23. Okay. Since you have found the resultant of E2 and E3, E2 ಮತ್ತು E3 the resultant find ಮಾಡಿದರೆ in E2 E3 ಮರ್ತು ಬಿಡ್ರಿ. You forget that E2 and E3. Now what we are having? We are having only two vectors now. We are having only two vectors. One is E23, and another one is E1. Another one is E1. These both are in same direction. You forget E3 and E2 now. Yakri, because you have found the resultant of that. So you forget it. Now only E1 and E23 are remaining. These both are in same direction. That's why resultant electric field at C. Here I will write resultant electric field at C. Sorry, resultant electric field at C is E is equal to E23 plus E1. So ನಮಗೆ E23 plus E1 ಅಂತ ಗೊತ್ತಾಯ್ತು. So ಈಗ ನಾವು E1 find ಮಾಡಬೇಕು. So let us find out E1 first. E23 value ಅಂತೂ ನಿಮಗೆ ಗೊತ್ತದೆ. E1 find ಮಾಡಬೇಕು. So let us calculate E1. Sorry. Let us calculate E1. Okay. First ನಾವು E1 calculate ಮಾಡೋಣ, ಆಮೇಲೆ resultant calculate ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay. So let us find out E1. E1, let us calculate E1. E1 is equal to, E1 means it is electric field of plus 4 nanocoulomb which is at A. How much is the value of this diagonal distance? It is 2 root 2, right? Either the 2 centimeter ತಗೊಂಡ್ರಿ, either the 2 centimeter ತಗೊಂಡ್ರಿ. But E 4 nanocoulomb, the distance 2 centimeter ಅಲ್ಲ. It is 2 root 2. Correct? So here I will write the formula first. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. And it is Q divided by R square. ಅಥವಾ Q1 divided by R square. What is 1 by 4 pi epsilon naught? It is 9 into 10 raised to 9. What is Q1? Q1 is 4 nanocoulomb. 4 into 10 to the power minus 9. Divided by, what is R square? R is 2 root 2. Then meter 2 root 2 into 10 to the power minus 2 whole square. Correct? So 10 to the power plus 9 minus 9 will get cancelled. What you will get? 9 into 4, 36. Divided by 2 root 2 square. 2 square will be 4. 2 square will be 4. Sorry. 2 square is 4 and root 2 square is 2 and 10 to the power minus 2 square is 10 to the power minus 4. Correct? So here it will be 2 ones are, 2 ones are, and sorry, I will take it like this, 4 ones are 4 nines are 36. So 9 divided by 2. 9 divided by 2 means it will be 4.5. 10 to the power minus 4 ಮೇಲ್ಗಡೆ ಬಂತಪ್ಪ ಅಂದ್ರೆ 10 to the power plus 4 Newton per coulomb. This much will be the electric field number 1. Electric field number 1. This much is electric field number 1. Next, now let us calculate the resultant electric field at C. Resultant electric field at C. Since E23 and E1 are in same direction, we have to add them. How much is E23? E23 is 9 root 2, 9 root 2 into 10 to the power plus 4. E1 is 4.5 into 10 to the power plus 4. Correct? So, ille na 10 to the power plus 4 common togoboda. If I take 10 to the power plus 4 common, I will get it as 9 root 2 plus 4.5. So, let us find the value of 9 root 2 then. Value of 9 root 2. See, root 2, 1.414, right? So, 9 into 1.414, this is 12.726. So, this is 12.726 plus 4.5 into 10 to the power plus 4. Okay, add plus 4 for this, sorry, plus 4.5 for this, 4.5. This is 17.226. So, 17.226 into 10 to the power plus 4 Newton per coulomb. This much is the electric field at the fourth corner. Istu namaga electric field irtadri fourth corner. Correct? Here we have to understand one more thing. Innond situation nimage bere kottare tough ante examiner, if you want to set the same question for different level antandre idrage ಸ್ವಲ್ಪ difficulty ಹೆಚ್ಚು ಮಾಡೋದಿದ್ದಂದ್ರೆ ಏನು ಮಾಡ್ತಾನೆ, ಇಲ್ಲೇ ನಮಗೆ E2 ಮತ್ತು E3 ಎರಡು ಈಕ್ವಲ್ ಅದಾವೆ. E2 and E3 both are equal, so the resultant is exactly along E1. That's why you added E23 and E1. E23 ಮತ್ತು E1 ನೀವು ಆಡ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಿಮಗೆ ಆನ್ಸರ್ ಬಂತು. Suppose E2 and E3 are not equal. If E2 and E3 are not equal, then E23 will not come exactly along E1. Either it will come close to E2 or close to E3. It will not be along E1. Avaga, you cannot add E23 and E1 because they are not on the same straight line, same direction. Add madak barangilla. Correct? So you cannot add them. Avaga en madbekri? At that time you don't find out E23. Don't find out E23. Better than that, what you do? See, this is E3, this is E3, this is E2, right? And this is E1. This is E1. This angle is 45 degree. We know that because it is acting along the diagonal of the square. This angle is 45 degree. So, in madri, instead of finding the resultant of E2 and E3, you resolve E1. E1 resolve madri. You will get E1 cos 45 degree here and E1 sin 45 degree here. E1 sin 45 degree. After resolving, you forget this E1. E1 you marthu bidri. You forget this, right? After forgetting this E1, you will get two vectors here. One do E1 cos 45 degree and E3. Both are in same direction. You add these both. E2 and E1 sin 45 degree both are in same direction. You add these both. So you will get one vector here, one vector here. And these two vectors are perpendicular to each other. Let me say this is EX. EX antare E1 cos 45 plus E3. Let me call this one as EY. EY means it is E2 plus E1 sin 45 degree. So EX and EY are perpendicular to each other. So resultant of these two will be root of EX square plus EY square. Istu namaga irtadri. Correct? So illige niಮಗೆ resultant ಸಿಗ್ತದ್ರಿ. Right? When E3 and E2 perpendicular vectors ಏನದಾವ equal ಇರದೇ ಇದ್ದಾಗ, when they are not equal, at that time you can solve it like this. ಈಗಂತೂ equal ಅದಾವ್ರಿ, equal ಇದ್ರಂತ ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Right? Okay, let us move to the next question then. Hope you are understanding. Okay, next question is 4 charges plus 4 coulomb minus 3 coulomb plus 2 coulomb plus 3 coulomb are placed at the corners of a square of each side 1 meter. Find electric field at the center of the square and also the direction. Okay, so let us find the electric field at the center of the square. Again, it is the question on electric field at the center of the square, right? So let us take the square first. Okay, this is the square. Now, the square ಮೇಲೆ ನಮಗೆ ಚಾರ್ಜಸ್ ನೋಡ್ರಿ ಎಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. Here we have plus 4 coulomb, here we have minus 3 coulomb, here we have plus 2 coulomb, and here we have plus 3 coulomb. plus 3 coulomb, right? So center ಒಳಗೆ ನಮಗೆ electric field ಕೇಳಿದ್ದಾರೆ. So what you do, you draw the diagonals first. Okay, let me draw the diagonals. This is one diagonal and this is another diagonal. This is center of the square. This is center of the square. Okay, let me call the square as A, B, C, D. Side of the square namak 1 meter kottidare. If side of the square is 1 meter, how much will be the half of the diagonal? OA equal to OB equal to OC equal to OD. This is 1 by root 2. X by root 2. 1 by root 2 meter. Okay, we have to find out electric field at the center O. Center ಒಳಗೆ ನಾವು electric field find ಮಾಡಬೇಕು. So electric field at the center find ಮಾಡಬೇಕಾದ್ರೆ first mark the direction of the electric fields. How many fields will be there? Total there are 1, 2, 3, 4 charges. If there are 4 charges, 4 electric fields will be there, right? So I will mark the direction of the electric fields. Plus 4 coulomb, positive charge, so radially out from the point. Positive charge andre away from the charge. ಇದೆಲ್ಲ ನಿಮಗೆ already ಗೊತ್ತಿದೆ, previous questions ಒಳಗೆ ಹೇಳಿದ್ದೀನಿ, so I am doing it fast. Okay, next. Minus 3 towards the charge, so electric field will be in this direction, correct? Next, plus 2 positive charge away from the charge, it has to be in this direction, correct? Next, plus 3 positive charge, so it has to be away from the charge, adu namagu ee direction ದಾಗ ಇರಬೇಕು, correct? It has to be in this direction. So totally 4 electric fields we have marked. So let us name the electric fields. Plus 4 ಇತರದ electric field ಈ ಕಡೆ ಬಂತ, I will call it as E1. Minus 3 ಇತರದ electric field ಈ ಕಡೆ ಬಂತ, I will call it as E2. Minus plus 2 ಇತರದ electric field away ಬಂತ, ಇದು ನಾ E3 ಅಂತ ಬರಿತೀನಿ. Plus 3 the electric field ಈ ಕಡೆದ, I will call it as E4. So these many electric fields we are having, correct? So here what we have to do is we have to find out the electric fields. ಇಲ್ಲಿ electric fields ನಾವು find ಮಾಡಬೇಕು. Okay, electric field find ಮಾಡಬೇಕಾದ್ರೆ ನೋಡ್ರಿ, ಇಲ್ಲೇ we are having 4 electric fields. We have to calculate all these 4 electric fields. I will tell you how to calculate these electric fields and how to calculate the resultant. You solve it on your own. ಇದನ್ನ ಕಂಪ್ಲೀಟ್ ನಾ ಸಾಲ್ವ್ ಮಾಡೋದಿಲ್ಲ, I will just tell you the method how to solve. ಆ ಮೆಥಡ್ ಹೇಳ್ತೀನಿ, ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ ನೀವು ಅದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ಬಿಡ್ರಿ. ಈಗ ಇಲ್ಲೇ E1, E2, E3 ಇವಂತೂ ಫೈಂಡ್ ಮಾಡಲಿಕ್ಕೆ ನಿಮ್ಮ ಹತ್ರ ಫಾರ್ಮುಲಾ ಅದ. ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ. ಸೊ ಫಾರ್ಮುಲಾ ಇಸ್ E is equal to 1 by 4 pi epsilon naught. Use the formula. E is equal to 1 by 4 pi epsilon naught Q divided by R square. Point charge is the formula. If you want even, substitute 4 coulomb and distance is again the same, 1 by root 2. ನೋಡ್ರಿ, plus 4 coulomb ಡಿಸ್ಟೆನ್ಸ್ ನಮಗೆ ಅಷ್ಟೇ ಅದ, minus 3 coulomb ಡಿಸ್ಟೆನ್ಸ್ ಅಷ್ಟೇ ಅದ, plus 2 coulomb ಅಷ್ಟೇ ಅದ, plus 3 coulomb ಅದಷ್ಟೇ. So distance R for all the charges is 1 by root 2. It is same. E1 ಇದ್ರೆ Q1 substitute ಮಾಡ್ರಿ, this is Q1. E2 3, don't take minus, substitute as 3 only, because on the basis of minus only we have put the direction. Now direction ಹಾಕ್ತೀವಿ. So ಇಲ್ಲಿ sign ಹಾಕ್ಲಿಕ್ಕೆ ಹೋಗ್ಬೇಡ್ರಿ, don't put the sign, just take the magnitude of that, ಅಂದ್ರೆ 3 as it is 3 ಅಂತ ತಗೊಳ್ರಿ, don't take minus 3. Okay, so using this formula you will calculate E1, E2, E3, E4. ಇವೆಲ್ಲ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಿ. See, E1 and E3 both are on the same straight line and they are opposite in direction. So ಇದರದ resultant ಇಲ್ಲೇ ನೋಡ್ರಿ, ಇಲ್ಲೆಲ್ಲ ನೀವು ಫೈಂಡ್ ಮಾಡ್ತೀರಾ. You will find E1 you will find, E2 you will find, E3 you will find, E4 you will find. All these electric fields you will find by using this formula. After getting all those electric fields, see, E1 and E3 are on same straight line. They are acting on same straight line, but they are opposite in direction. So resultant of these two, ಈಗ ನೋಡ್ರಿ, E1 is electric field due to plus 4 coulomb. E3 is electric field due to plus 2 coulomb. Which will be greater? E1 will be greater. Why? Because this charge is greater than this charge. Distance ಅಂತೂ ಎರಡು ತರದ್ದು ಸೇಮ್ ಅದಾವ, but E charge ಜಾಸ್ತಿ ಅದ, E charge ಕಮ್ಮಿ ಅದ, so E1 will be greater. So resultant of these two will be E1 minus E3. Why I am taking E1 minus E3? Because E1 is greater, E3 is smaller. Okay, ನಿಮಗೆ ಇದು resultant ಬರ್ತದ್ರಿ, you will get something Newton per coulomb ಅಂತ ಯೂನಿಟ್ ಬರೀರಿ. ಈಗ E1 3 ಅಂತ ಏನು ನಮಗೆ ವೆಕ್ಟರ್ ಬಂತ, in which direction this will be? E1 3 will be in the direction of greater vector. ಅಂದ್ರೆ E1 ಯಾವ ಡೈರೆಕ್ಷನ್ ಒಳಗದ ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ E1 3 resultant vector will be. It means the resultant vector E1 3 will be in this direction. E1 3 will be in this direction, in the direction of E1. Why? Because E1 is greater than E3. If E3 was greater, other E1 3 ನಮಗೆ ಈ ಕಡೆ ಬರ್ತಿತ್ತು. Correct? Okay. Well, after that, find out, you have already found E2 and E4. E2, E4 find ಮಾಡಿದಿರಿ. So ಅವು ಎರಡು ನಮಗೆ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ದಾಗ ಅದಾವ್ರಿ. They are not in opposite direction. They are in same direction. So add both of this, E2 plus E4. You add both of this, you will get the resultant, and this resultant will be along these two directions only. Either direction ಒಳಗೆ ನಮಗೆ ಇರ್ತದೆ. So this is E24. This is E24. Correct? So finally, we are having two vectors now. We are left with two vectors. One is E13, and another one is E24. Another one is E24. These are the two vectors we are left with, E13, E24. These both are perpendicular to each other because diagonals will always be perpendicular to each other. ಒಂದಕ್ಕೊಂದು perpendicular ಇರ್ತವೆ. So resultant of these two electric fields, I will take it as E. This resultant electric field E will be equal to root of E13 square plus E24 square. Why? Because these both are perpendicular. These both are perpendicular. So you will find resultant electric field here. ಯಾಕಂದ್ರೆ ನಿಮಗೆ ಆಲ್ರೆಡಿ E13 ಬಂದದ, E24 ಬಂದದ್ರಿ, ನಿಮಗೆ resultant electric field ಬರ್ತದ್ರಿ. Okay, you got resultant electric field, Newton per coulomb. Correct? So this much electric field you will get. ಇದು ನಿಮಗೆ ವ್ಯಾಲ್ಯೂ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ರಿ. Okay, resultant electric field ಬಂತು. See, they are asking to find electric field at the center of square and also the direction. They are asking you the direction of this electric field. Direction of this electric field. So to find out the direction of electric field, what you do? You take an angle theta here. This angle theta anta tagolri. You take this angle as theta. Correct? So after taking this angle theta, apply the formula. Formula apply ಮಾಡ್ರಿ. ಈಗ ನಮಗೆ ಇದು angle theta ಬೇಕಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಅಥವಾ ಅದನ್ನ alpha ಅಂತ ತಗೊಳ್ರಿ. ನಮ್ದು ಏನು ಫಾರ್ಮುಲಾ ಇದೆ, tan alpha is equal to that alpha formula we can take. Okay, let me take this as alpha. So we have to find the direction. To find the direction, use the formula tan alpha is equal to q sin theta divided by p plus q cos theta. What is theta? Theta is the angle between the two vectors. For example, ಇದನ್ನ p ಅಂತ ತಗೊಳ್ರಿ, ಇದನ್ನ q ಅಂತ ತಗೊಳ್ರಿ, ಇವೆರಡರ ನಡುವಿನ angle ರೀ. It is 90 degree. So cos 90 will be 0, sin 90 will be 1. So ಇದು ನಮಗೆ ಏನು ಬರ್ತದ್ರಿ, q divided by p. It means I can take it as E24 divided by E13 ಅಂತನ ಬರಿಬಹುದು. E24 divided by E13. Correct? So tan alpha is equal to, you know the value of E24, you know the value of E13, you substitute them, you will get tan alpha is equal to something. Then alpha is equal to tan inverse of this value. Find it in log table, you will get the answer in degrees as well as minutes. Right? This is how we have to find out the resultant electric field as well as direction. Let us go to the next question then. See, next question is, 2 point charges 5 microcoulomb and minus 5 microcoulomb are located at A and B respectively, separated by a distance of 0.2 meter in vacuum. What is electric field at midpoint O of the line joining the two charges? Okay, we are having two charges here. We are having two charges, they are placed on a straight line. Okay, this is a straight line and here we are having two charges placed. Okay, here we are having two charges placed. Okay, this is one and this is another charge. So two charges 5 microcoulomb and minus 5 microcoulomb. Let me call the first charge as 5 microcoulomb, q1 as 5 microcoulomb and q2 as minus 5 microcoulomb. This is point A and this is point B. Correct? Distance between them is 0.2 meter. Okay, distance between them is 0.2 meter is the distance between those two charges. What they are asking, first one, what is electric field at midpoint O of the line joining two charges? Okay, let me say this is the midpoint and it is called O. We have to find out electric field at this point O. This point ಒಳಗೆ electric field ನಾವು find ಮಾಡಬೇಕು. Next, if a negative test charge of magnitude 2 nanocoulomb is placed at point O, what is the force experienced by it? Okay, first let us find electric field at point O. First question. See, first what you do, you mark the directions. How many electric fields has to be at point O? Two electric fields, because there are two charges, plus 5, minus 5. Due to plus 5 microcoulomb, electric field has to be away from the charge, radial outwards from the charge. So I will mark it in this direction. Correct? This is E1, electric field due to the first charge. Next, electric field of minus 5 microcoulomb, it has to be towards the charge. So towards the charge idre adanna ee kade mark ಮಾಡಬೇಕು. Towards the charge idre na adanna towards the charge ee ತರ ತೋರಿಸಬೇಕು. I have to show it in this direction. Correct? Okay, so this is E2. This is E2. Correct? E2. Now we have to calculate this E1 and E2. Will these both electric fields be same? Look at the distance as well as charges. Charge is 5 micro, charge is 5 micro. Magnitude the same. Distance OA, OB, midpoint under midpoint andmele distance between O and A, this will be 0.1 meter. And distance between O and B, this will be 0.1 meter. Distance is same, charge is same, so fields will be same. Correct? So here E1 and E2 both are equal. Heng equal anta namagu gottaithe because both the charges are same and the distances are same. That's why both are equal. So let us calculate both together. Okay, so the formula is 1 by 4 pi epsilon naught q divided by r square. 1 by 4 pi epsilon naught is 9 into 10 raised to 9. How much is q? Q is 5 microcoulomb. Just to take the magnitude, don't take the sign. 5 micro. Micro means 10 to the power minus 6. Divided by r square. Distance is 0.1, 0.1. So 0.1 whole square. 9 into 5 will be 45. 9 into 5 is 45. 10 to the power plus 9 minus 6 will be 10 to the power plus 3. 0.1 whole square means it is 0.01. 0.01. I can write this one as 45 into 10 raised to 3 divided by 0.01 ಅಂತಂದ್ರೆ then 10 to the power minus 2 ಅಂತ ಬರೀಬಹುದು. 10 to the power minus 2. If I take 10 to the power minus 2 to the numerator, it will be 10 to the power plus 3 plus 2, that is 10 to the power plus 5. So 45 into 10 to the power plus 5 Newton per coulomb. This much is the electric field at the midpoint O. Electric field at the these are the values of E1 and E2. These are the values of E1 and E2. So E1 is equal to E2 is equal to this much we will get. See, these both electric fields are equal and they are in same direction. E1 and E2 both are in same direction. So resultant electric field at point O will be E1 plus E2. Why we are adding? Because they are in same direction. Because they are in same direction. Since E1 and E2 both are equal, I will write it as 2E1. Andre E1 plus E1 anta tagondre 2E1. E1 value nimage already gottada 45 into 10 to the power 5. So it is 2 into 45 into 10 to the power plus 5. So 2 into 45 is 90 into 10 to the power plus 5 Newton per coulomb. So this much is the electric field at point O. You got the electric field at point O, that is 90 into 10 to the power plus 5. Second question, they are asking us if a negative test charge of magnitude 2 nanocoulomb is placed at point O. ಈ point O ಒಳಗೆ ಒಂದು negative test charge Q is equal to minus 2 nanocoulomb ಅಂತ ಒಂದು ಚಾರ್ಜ್ ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ಕೊಂಡ್ರೆ how much will be the force experienced by it? How much is the force experienced? See, to calculate the force experienced by minus 2 nanocoulomb, ಈಗ ನಮಗೆ ಇದು ಆಲ್ರೆಡಿ ಗೊತ್ತದ್ರಿ ಏನ ಮೈನಸ್ ಕ್ಯೂ ದಿಂದ ಒಂದು ಫೋರ್ಸ್ ಇದ್ರ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತದೆ, ಪ್ಲಸ್ 5 ದಿಂದ ಒಂದು ಫೋರ್ಸ್ ಇದ್ರ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತದ್ರಿ, minus 5 ದಿಂದ ಒಂದು ಫೋರ್ಸ್ ಇದ್ರ ಮೇಲೆ ಆಕ್ಟ್ ಆಗ್ತದೆ. So two forces will be there, all that we know. But don't apply that concept. You already know what is the electric field at point O. Point O ಒಳಗೆ electric field ಎಷ್ಟದ ಅಂತ ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದೆ. So instead of that, you use this formula. F is equal to E into Q. EO into Q. EO andre you know the electric field at that point. So directly use this formula. So EO, electric field at point O, that is 90 into 10 raised to 5. Charge at point O, what we have kept is 2 nanocoulomb. 2 nano. Just take the magnitude, 2 nano, just take the magnitude, right? Okay, so 90 into 2 will be 180 into 10 to the power plus 5 minus 9 will be minus 4, correct? Or simply I can write it as 18 into 10 to the power minus 3 Newton, or simply I can write it as 18 millinewton. This much is the force acting on that charge. Clear there? Understood? Okay, let us go to the next question then. Okay, 2 point charges 5 nanocoulomb and 20 nanocoulomb are separated by distance of 2 meter. Find a point on the line joining them where the electric field is 0. Okay, so there are again two charges here. There are again two charges which are kept on a straight line and separated by certain distance. So this is the straight line, let me say. Okay, this is the straight line, and on this straight line there are two charges kept. So Q1 it is 5 nanocoulomb. Q2 it is 20 nanocoulomb. Q2 it is 20 nanocoulomb. Distance between the two charges is 2 meter. Distance between the two charges is 2 meter. This much is the distance. Find a point on the line joining them where the electric field is 0. ಅಂದ್ರೆ ಈ ಎರಡು ಚಾರ್ಜಸ್ ಜಾಯಿನ್ ಮಾಡೋದ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಇದೆ, ಆ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಮೇಲೆ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ದಾಗ ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 0 ಅದ. ಆ ಪಾಯಿಂಟ್ ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಆ ಪಾಯಿಂಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. See, it is not exactly midpoint of the line joining the straight line. when it will be midpoint if both the charges are equal and same polarity. ಎರಡು ಪಾಸಿಟಿವ್ ಮತ್ತು ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಚಾರ್ಜಸ್ ಅಥವಾ ಎರಡು ನೆಗೆಟಿವ್ ಅಂಡ್ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ನೆಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ 0 at the midpoint. Since the charges are not equal, net electric field 0 will not be at the midpoint. Midpoint ಒಳಗೆ net electric field 0 ಇರೋದಿಲ್ಲ. Okay, let me say that point is here, somewhere here. ಈ ಪಾಯಿಂಟ್ ಒಳಗೆ ನಮಗೆ net electric field 0 ಅದ ಅಂತ ಇಟ್ಕೋ. Let the distance of that point from Q1 be taken as x. ಅದು ನಮಗೆ x ಅಂತಿರಲಿ. If it is x from Q1, then how much it will be from Q2? It will be 2 minus x from Q2. 2 minus x from Q2. Okay. So first you mark the direction of the fields. How many fields will be there? 2 fields because there are 2 charges. This is positive electric field radial outwards. I will show it here. Electric field radial outwards. And this is also positive. This is also positive electric field radial outwards. So I will show it here. Obviously fields has to be in opposite direction, then only they will get cancelled and resultant electric field you will get 0, otherwise no. Electric field of Q1 I will write it as E1. Electric field of Q2 I will write it as E2. See, if you want the resultant of these two electric fields 0, then obviously these two electric fields must be equal. If ಎರಡು equal ಇದ್ರೆ ಮಾತ್ರ ಎರಡು cancel out ಆಗಿ resultant electric field ನಿಮಗೆ 0 ಬರಲಿಕ್ಕೆ ಸಾಧ್ಯದ. Correct? That's why these both must be equal anta namak already gottaytu. Or simply you can calculate it like this also. See, E resultant electric field, since both are in opposite direction, idanna E1 minus E2 anta tagobodu. E1 minus E2 because they are opposite in direction. How much resultant electric field we want? We want it as 0 only. Adu namak 0 ne bekaitri. So 0 is equal to E1 minus E2. Okay, 0 ಬಿಡ್ರಿ. ಈಗ ನಮಗೆ ಇದು E1 minus E2 ಅದಲ್ಲ, so I will get it as E1 is equal to E2. ನಾ ಇದನ್ನ E2 ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ನಂಗೆ E1 equal to E2 ಬಂತು. So using this, now you have to solve. E1 electric field of 5 nanocoulomb, so it will be 1 by 4 pi epsilon naught Q1, that is 5 nanocoulomb, 5 into 10 to the power minus 9 divided by square of the distance, that is x square, equal to E2 1 by 4 pi epsilon naught, charge Q2 is 20 nanocoulomb, 20 into 10 to the power minus 9 divided by square of the distance between them, 2 minus x whole square. 1 by 4 pi epsilon from this side, 1 by 4 pi epsilon from this side will get cancelled. 10 to the power minus 9, 10 to the power minus 9 will get cancelled. 5 ones are 5 4s are 20 will get cancelled. What you will get? You will get it as 1 divided by x square. 1 divided by x square is equal to 4 divided by 2 minus x whole square. 4 divided by 2 minus x whole square. Since everything is a perfect square, take square roots on both the sides. Square root on this side, square root on this side. You will get it as 1 divided by x is equal to 2 divided by 2 minus x. Cross multiply, you will get it as 2 minus x is equal to 2x. X is multiply. So, this x na akade tagondre it will be 2 is equal to 3x. X akade hodre plus aayta 3x. So, x is equal to 2 by 3 meters. X equal to 2 by 3 meters. Right? You got the value of x equal to 2 by 3 meters. If you want this distance, 2 minus 2 by 3 you take, you will get that answer. Right? This is how we have to calculate it. Clear? Okay. Next, let us go to one more last question. This question appeared in March 2025. Andre ಈಗ last year ಬಿದ್ದಿದ್ದಾರೆ. Simple question adare, you can solve it easily. Right? See, a uniform charged spherical shell of radius 10 centimeter has a surface charge density of 16 microcoulomb per centimeter square. Okay. Find the electric field due to the shell at a distance of 20 centimeter from the center of the cell, 5 centimeter from the center of the cell. Radius of the cell 10 centimeter. Okay. Shell they have given us a shell. Okay, so this is the So this is the shell. This is the shell. Radius of the shell is So ಇದು center ಅಂತ ನಾವು ತಗೊಂಡ್ರೆ radius of the shell ನಮಗೆ ಎಷ್ಟು ಇದೆ? Radius of the cell is 10 centimeter. R is equal to 10 centimeter. So ಈಗ ನಮಗೆ ಎರಡು ಪಾಯಿಂಟ್ ದಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ಇನ್ ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳತ್ತಾರೆ at 2 different points. First point is here, A ಅಂತ ಏನದ, A question ಏನದ ಅದು A point ಅನ್ನ ಇಲ್ಲಿ ತಗೋತೀನಿ. That is at 20 centimeter from the center of the cell. center of the cell ದಿಂದ ಅದು ನಮಗೆ 20 centimeter distance ಒಳಗದ. This is first point. B point ಏನದ, it is 5 centimeter from the center of the cell. 5 centimeter means, see, radius of the shell is 10 centimeter. 5 centimeter from the center ಅಂದ್ರೆ it is inside the shell. So here it is, inside the shell. ಈಗ ನಮಗೆ ಇಷ್ಟಂತೂ ಗೊತ್ತಂದ್ರೆ charges always reside on the surface of the shell. So electric field inside the shell will be 0. ಅಂದ್ರೆ you already got to know electric field here will be 0. B point ಒಳಗೆ ನಮಗೆ electric field 0 ಅದ ಅಂತ already ಗೊತ್ತಾಯ್ತು, right? ಅದನ್ನ ನಾವು ಬರಿಬೇಕಲ್ಲ reason. Surface charge density of this shell is given, it is 16 microcoulomb per centimeter square. Per centimeter square. Find electric field due to the shell at a distance. Okay, ಇಲ್ಲಿ ನಮಗೆ electric field find ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. So electric field at point A, electric field at point A, ಇದನ್ನ ನಾ ಬರಿತೀನಿ. Since the point is outside the shell, when the point is outside the shell, consider the shell as a point charge which is at the center of the shell. So point charge the electric field ಏನದ, ಅದ electric field ಇದಕ್ಕೆ ಬರ್ತದೆ. Outside the shell, electric field is same as the electric field of point charge. Electric field of point charge is 1 by 4 pi epsilon naught q divided by r square. Okay, 1 by 4 pi epsilon naught is 9 into 10 raised to 9. How much is the charge? Okay, ನಮಗೆ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಕೊಟ್ಟಿಲ್ಲ, ಡೆನ್ಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇದನ್ನ ಡೆನ್ಸಿಟಿ ಟರ್ಮ್ದಾಗ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋಣ. ಲೆಟ್ ಅಸ್ ಎಕ್ಸ್ಪ್ರೆಸ್ ದಿಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಡೆನ್ಸಿಟಿ. ವಿ ನೋ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ. ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂತಂದ್ರೆ ನಮಗೆ ಅದನ್ನ ಯಾವ ತರದಿಂದ ಬರೀತೀವಿ? ವಿ ರೈಟ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. Surface charge density means it is charge per unit area, right? Then charge is equal to surface charge density into area. Area of the sphere ಏನಂತ ಬರೀತೀವಿ? 4 pi r square ಅಂತ ಬರೀತೀವಿ. Area of the sphere, substitute that there. So we'll get it as 1 divided by 4 pi epsilon naught. This is sigma into 4 pi capital R square divided by small r square. Correct? 4 pi capital R square. Okay, 4 pi and 4 pi will get cancelled. What you will get? You will get sigma into capital R square divided by epsilon naught into small r square. Now substitute the values. How much is sigma? Sigma is, nodri, idu per centimeter square ಒಳಗದ, ಇದು centimeter ಒಳಗದ, ಇದು centimeter ಒಳಗದ. ಈಗ 16 microcoulomb per centimeter square, you have to convert it to per meter square. ಅದನ್ನ per meter square ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಯೂನಿಟ್ ನಾಗ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ. ಸೊ ಇಲ್ಲೇ 16 microcoulomb ಏನದ per centimeter square ಅದರ, per centimeter square, microcoulomb per centimeter square. ಈ ಸೆಂಟಿಮೀಟರ್ ಇದ್ದದು ಮೀಟರ್ ಕನ್ವರ್ಟ್ ಆಗಬೇಕಾದ್ರೆ, ಸೆಂಟಿಮೀಟರ್ ಇದ್ದದು ನೋಡ್ರಿ, ಸೆಂಟಿಮೀಟರ್ ಇದ್ದದು ಮೀಟರ್ಗೆ ನೀವು ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ 10 to the power minus 2. ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಇದ್ದದು ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕಂದ್ರೆ ಇದನ್ನ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೋಬೇಕು. ಅಂದ್ರೆ -2 into 2 will be 10 to the power minus 4. So this is 10 to the power minus 4 meter square ಅಂತ ನಾ ಬರೀತೀನಿ. ಹಂಗಿದ್ರೆ ಇದು ನಮಗೆ ಏನಾಗ್ತದ್ರಿ ವ್ಯಾಲ್ಯೂ? What I will get? I will get it as 16 into 10 to the power plus 4 microcoulomb per meter square. This much I will get. Correct? So substitute that value here. Sigma, that is 16 into 10 to the power plus 4 microcoulomb per second square. So a micro nu ತೆಗೆದು ಹಾಕ್ರಿ. 16 into 10 to the power plus 4 into 10 to the power minus 6 coulomb per meter square. ಈಗ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಯೂನಿಟ್ ಬಂತು. -6 plus 4 ಅಂತಂದ್ರೆ 16 into 10 to the power minus 2 coulomb per meter square. So you take it as -2 only then. Correct? Then you -2 ಅಂತ ಹೇಳಿ ತಗೊಂಡ್ಬಿಡ್ರಿ. Okay, let us take it as -2. 16 into 10 to the power minus 2. Okay, r square, r is how much? 10 centimeter. ಅದನ್ನು ಮೀಟರ್ ಒಳಗೆ ತಗೊಳ್ರಿ. So 10 into 10 to the power minus 2 whole square divided by epsilon naught. Epsilon naught is 8.854 into 10 to the power minus 12. ಅದರ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿರಬೇಕು. Epsilon naught smaller, ಅದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಅಂದರೆ epsilon naught. Smaller, it is 20 centimeter distance. ಅದನ್ನು ಮೀಟರ್ ಒಳಗೆ ತಗೊಳ್ರಿ. 20 into 10 to the power minus 2 whole square. Correct? Okay, we have to simplify this now. ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. Let us take it here. So this is 16 into 10 to the power minus 2 into 10 square into 10 to the power minus 2 whole square ಅಂದರೆ 10 to the power minus 4. So divided by 8.854 is the 20 square adare. So 8.854 into 10 to the power minus 12 into 20 square is 400. 20 square is 400 into 10 to the power minus 4. 10 to the power minus 4. Minus 2 square is minus 4. 10 to the power minus 4, 10 to the power minus 4 will get cancelled. 10 to the power plus 2, 10 to the power plus 2. Double 0 under 10 to the power plus 2. So this is 4 1s are 4 4s are 16. 10 to the power minus 2, here it is minus 12. So ಇಲ್ಲಿ ನೀವು ಏನು ಮಾಡಬಹುದು? ಇದರಾಗಿಂದ -2, ಇದರಾಗಿಂದ -2 ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬಹುದು. So ಇಲ್ಲಿ 10 to the power minus 10 ಉಳಿದಿದೆ. So in the numerator we got 4 divided by, here we are having 8.854 into 10 to the power minus 10. 10 to the power minus 10 we got. 10 to the power minus 10. Okay, let us divide this. Let us divide this. So if we divide, it is 4 divided by 8.854. 4 divided by 8.854, it is 0.45177. So it is 0.45177 into 10 to the power plus 10 Newton per coulomb. This much will be the electric field at A, right? This much will be the electric field at A. And what about electric field at B? Electric field at B will be 0 because it is inside point. Because it is inside point. Clear? Hope you have understood all the numericals. I have covered all the types of numericals possible from this chapter. Dear students, if you like the content of this channel, please don't forget to subscribe the channel, and please share the video as well as share the channel with your friends. Suggest the channel for your juniors, seniors as well as for your friends, right? Thank you so much. Please keep watching and supporting the channel. If you need anything else, please put a comment in the comment box. I will surely make the video on that. I'm here to support you until your board exam, your CET, your NEET as well as JEE, right? Thank you. Please keep watching. We'll meet again in the next video.